A very good morning to everyone in this session. So today we are going to talk about the tuple relational calculus. So it is a part of the database management system. So in the previous sessions we saw about how a relational calculus works, a relational algebra works, and before that we saw what an entity is and what a relationship is and how they are related to each other. Okay, so for the continuation of your relational calculus, I'm just giving a preview of what a relational algebra is. So as we already know, it is just a part of expressing an query. Okay, so whenever you write a query, it can be expressed in terms of statements, SQL statements, or otherwise it can also be referred based upon your relational algebra pattern, which is an expression, or your tuple calculus pattern, which is also a representation of a query. So whenever you write a query, it can be represented based upon different format. Okay, it can also be represented via your domain calculus as well. Okay, so before getting into the actual tuple calculus, we will just clarify, or we'll just go through about the relational calculus. So we had notations denoting your tuple calculus. We had sigma, we had your pi, identifying your projection and your selection operation, and we had many other operations which is carried out in along with it. Okay, so first we are just going to first we are going to continue with the join operations of your relational algebra. Okay, so inside your relational algebra, the main two important thing that we saw is that your selection operation and your projection operation. So selection operation, it concentrates mainly on your selection part. That is, it depends upon the tuple that you have inside your table. Okay, so every tuple that you have inside your table is taken into consideration, whereas your projection operation extracts the value from your specific attributes. Okay, so based upon your attributes, which means in turns it is your field name or your column name, right? So it extracts the values from your attributes. Okay, you're going to project one column or you're going to project one particular value. So this is all about your basics of your relational algebra. And the next point that we are just going to see based upon your operations is that your joins. So when you talk about joins, it is that you have n number of joins that is available. Okay, so either it can be the various type of joins. Okay, you can have joins wherein which your joins can work with inner join, natural join. You can have outer join, you have left outer join, you have right outer join, and so many type of joins that you can implement in a particular table. So the basic terminology or the basic conditions in which your join can perform is that based upon the column that is identified uniquely. Okay, if you want to join particular records of two tables, we prefer joining that via your primary key or your foreign key or any keys that is available. Either it can be candidate key or super key as well, or you can refer any other attribute inside that particular entity. So other than that, if there is a table, if there is two tables and you don't have any common attribute in that, you can just perform normal join. Okay, you can perform natural join, you can perform inner join, and you can obtain the values. Okay, so for specific functionalities, we go in for different type of joins. Okay, so here we're just going to before getting into what a join in a relational algebra, we're just going to see how your what are the basic joins that are available. Okay, so I'm just going to give a gist on how a join works in your DBMS. Okay, so that is your database. Okay, so there are major joins in your major joins in that is available in your SQL operation. So the first one is inner join. So when I talk about inner join, it specifies how a join operation happens. Okay, so it specifies how a join operation happens. So when you try to combine, okay, two tables, the common attributes, right? So the common values that is present in one particular in in both the tables. Okay, so if you have a table 1 T1, table 2 T2, then the common attributes of those two joins are collectively given as your output. So those type of join is called as your inner join. And next one is that you have your left join. Okay, so normal left join. Okay, it is a simplified form of a left join. So left join gives, if consider you have an entity R and another entity as S. So when you have these two entities with you and you have certain attributes, okay, so when you want to write a left join, only the values that are given in your given in the table 1 or your entity R, which is your left side, okay, which is your left join process, will be displayed. Okay, the join will return all the values from your left table and the matching values in the right table. Okay, so you will get whatever content there is in your R entity will be displayed. Okay, so this is if there is no value that is related to your other table. Okay, so consider there is no values. You have a table 1, 2, 3. You have your student details here, but the student details where he is related to your department details. Okay, so inside your department details you have your column name as email id, but at that time he has not given his email id. When you try to retrieve that value from there, it will show a null value. Okay, so null will be given inside that particular join. Okay, so I'm just giving a gist of what join is. When you talk about right join tells you how you can pick the value. Okay, so how you will be able to pick the value inside your right join. So inside your right join, all the values that is inside your right side entity, that is your S entity. So when you consider R and S as your entity, S entity is going to be your right side. So right side, all the values inside your right side is going to be displayed. Okay, if there is no matching values, again it will be returning a null value here. And next one is your full join. So full join is the combination of both your left and your right outer join. Okay, so it is a combination of both the values. Okay, so all the values, okay, all the values in your left table and your right table will be displayed. Joins the table from both the records. Okay, all the records inside, consider you have 4 records in one table and you have 3 records in other table. All the records from both the tables. So totally 7 records will be available. If any of the attribute value is missing in that particular table, you will be ending up with resulting null for that particular attribute. Okay, so this is how we talk about join. These are the basic type of joins. Okay, so your inner join, your outer join, your left join, right join, full join. Okay, so these are the basic joins. Other than that, we can see so many number of joins that is available inside your SQL. Okay, so for this particular session, I just gave a preview of how join works. So now we are just going to see how a join operation works in your relational algebra. Okay, so inside your relational algebra, if you want to understand join, okay, so if you want to understand join, you should know how it works. Okay, your join always gives your Cartesian product. Okay, so in the previous sessions we saw what a Cartesian product is, right? It gives the cross value of both the tables. Okay, so it produces, consider you have 3 records in a table, in one table, in table R, and you have 2 records in another table, that is going to be S. When you have a Cartesian product of this, the resulting join will be 6 values. Okay, so your resulting join will be 6 values. That is the Cartesian product of each and every join. So inside your join operation, there are so many number of divisions that is available that we are going to see inside this session. Okay, so your first value inside your join operation is that it is your outer join. So okay, you're just going to see theta join, you're going to see natural join, you're going to see outer join, and you're going to see full outer join, right outer join, and left outer join, all these joined together, and you have equi joins as well. Okay, so inside that, by definition, it is equivalent to performing selection using join predicate as selection formula. Join predicate as selection formula over Cartesian product. Okay, so as we already discussed, right, it's going to be a Cartesian product of R and S. Okay, so the output will be the multiplicated value of these two table rows. Okay, so the tuple is going to be highlighted, and the how many number of records depend upon the Cartesian product value. Okay, one of the most difficult operation to implement efficiently in RDBMS. Okay, so this is a very efficient way. So if you want to join two things, there should be some common thing inside that particular place, right? So inside that, if you don't have anything in common, if you don't if the operation is does not have anything, then there must be an option for combining two tables at a time. Okay, so consider you have a table where it has loan details. Okay, the loan name, loan number, everything can be given inside that table. But if you want to join that with your account details, so the bank can have a number of customers, the customer details has to be joined and checked whether there is going to be any loan that is uptime. Okay, if you don't have the common account details in your loan table, then you can't perform a query operation there. So at that time, what you can do, you can perform a join operation to combine these two tables, and you can implement your query for execution. Okay, so in the previous session when we saw about a gate question where they have asked about students and how many number of departments are available. Okay, so there was no common primary key constraint given inside. So instead of that, we just combined or we performed the inner join for all these. Instead of performing the common join, here we can perform an inner join for combining these two tables. Or if you want values that is very common, then you can perform an inner join. Or if you want to collect all the data, you can perform an outer join and retrieve that particular value. So this join operation helps in RDMS. One reason for RDBMS is that it has some performance problems. Okay, so even though it is most efficient, but there are certain performance issues. When you consider for every query you run for 10,000 records or 20,000 records, the optimization takes an upper hand. Okay, so optimization is very important because it in turn reflects the revenue, right? So whenever you write a query, you must keep in mind that the complete query will be optimized or not. Okay, so how much number of records it's going to take as an input. So when I say it is a Cartesian product, so consider there are 20,000 records in one table and 20,000 record in another table. So when you're going to give a Cartesian product, you know how huge the output is going to be, right? So whenever you write the record, I mean, whenever you write a query, your optimization, the query efficiency has to be considered. Okay, so this join at times provides a efficiency as well as the performance is sometimes a question mark. We are just going to see these types of join in today's session. Okay, so first one is your theta join, next one is your equi join, next one is your equi join, and next one is your natural join, and then your outer join and your semi join. Okay, so inside your outer join, okay, so we will see each and everything. All these joins are somewhere or the other. Okay, the theta join, equi join, and natural join, all these three joins are it is belong to the category of a inner join, where outer join and semi join it is just a combination of this join. Okay, outer joins, when you work with theta join and equi join, you get the intersection values between these two tables. But when you work with your outer join, you can get the values which are which are not only outside, not only common, but all the values can be used. Okay. Okay, so we'll just start off with your theta join. Okay, so when we talk about your theta join is nothing but a part of your inner join. Okay, so when you talk about your inner join, it helps you identifying your comparison condition. So this is how the infinity kind of symbol. Okay, so this symbol denotes your join operation. Okay, that is your basic join operation. So R is going to be an entity and S is going to be another entity. Okay, so R is going to be one entity, or it can be one particular table, and S is going to be your another particular table. Okay, so when you consider these two operations here, your R value gives your complete tables information, and S is going to be another tables information. When you are going to try comparing these two, the functionality whatever we are going to use is your less than equal to, greater than equal to or not equal to. Okay, so these are the predicate functions that we are going to use. The functionality whatever we are just going to use here, you have indicated F, which means that is going to be your predicate. Okay, your predicate is of the form R dot A1 and theta join of S dot bi. Okay, so you are going to perform a combination operation based upon certain condition. So that condition we can call it as your that comparison condition. Okay, so it is going to be a comparison condition. Okay, so that comparison condition is called as your predicate function here. Okay, so the definition, by definition, it defines the relationship that contains tuple satisfying the predicate f. The predicate f denotes your comparison condition from the Cartesian product of R and S. So if you have two entities, say R stands for your table phone and S stands for your table laptop. So you have two columns. Okay, if you're going to have two columns inside your R table, consider you're going to have the table value of phone. Okay, and in your S column, you're going to have your table value of laptop. Okay, the attributes for these two is going to be same. Okay, model and price, the model of the phone and price of the phone. And same way, if you have an S operation, I mean S entity, where S is your another entity that is going to denote your laptop. The attribute is going to be same here, model and price. Okay, so if a query is asked to you like find all the purchase the mobile laptop, but the mobile price has to be less than your laptop price. So when you look at this table here, you will have only mobile and your price. Okay, so your R entity will have only mobile values and your S entity will have the values of your laptop, even though the attribute name is same, but the value refers a different piece of information. So if you are just going to perform a theta operation, then you have to indicate that R is inner joined with S. Okay, along with inside your bracket, you have to mention based upon which functionality or which predicate function you are going to work. Okay, for example, if you're going to compare it with price, okay, if you're going to, I mean, extract the value, if you're going to do a selection operation from one particular table, okay, selection operation from both the table, then you have to give some comparison condition, that is your predicate function. Okay, mobile price less than your laptop price. Okay, if that is going to be your function. Okay, so you're just going to identify which all mobile price is less than the laptop price. Okay, so if you're going to filter that condition, your mobile has to be inner joined with your phone attribute, and then inside the bracket you have to mention your mobile dot price and less than or equal to your laptop dot price. Okay, so this less than condition identifies your predicate function. Okay, so your comparison operation here is going to be less than. Okay, so these are the comparison operators that can be given inside one particular function. Okay, so your less than, your greater than, equal to, or your equal to symbol. In the same theta join, okay, inside this theta join, instead of your comparison operation less than equal to, or greater than equal to, instead of using these four, you are using your equal to symbol. Then it tells you that this theta join becomes an equijoin. So inside your predicate function, if you are going to use your equal to symbol, okay, if you are going to use your equal to symbol, then this predicate function, this function becomes your equijoin. This theta join becomes your equijoin. Okay, so based upon the comparative condition, you can identify which type of join has been happened. Okay, so if you are just given a query stating to find out some value or combination value, then you can identify that easily with the help of your inner join. And if you are asked to write an expression, okay, if you're just asked to write an expression on your theta join, okay, you must be able to write that both the entities along with the condition, that is your predicate function. Okay, so the predicate function given inside your bracket and the output can be obtained based upon these conditions. Okay, next we are just given how to write a theta join. Okay, it can be rewritten into R, your functionality of your inner join, and based upon which condition it is. See, actually before, while identifying this itself, I mentioned that it is a selection operation. So they are just used your selection operation, and the functionality of your selection operation, it is going to work with your individual rows. So it is going to be a selection operation, and then you produce your Cartesian product of these two. Okay, if at all your theta join is used, whenever you use your theta join, then you will get an output based upon your R and S. The degree of a theta join is the sum of degree of operand relation R and S. Okay, so the number of operations that you do. Okay, the sum of relation. Okay, so that relation, the equal to relation, gives the degree of R and S. Okay, the degree of your theta join can be calculated with the help of your predicate function. So here in the previous example we saw equal to is going to be or less than is going to be your predicate function. If in the same query or the same expression, if you are going to use your equal to symbol, okay, then it is going to be your equijoin. Okay, so it's the same theta join process where the predicate function alone gives you an equal to value, then it becomes your theta join. If the predicate, that is what mentioned in the last row, if the predicate f contains only equality, then it is going to be a equijoin. Okay, so here an example of an equijoin is given. Okay, list the name and comment of all client who have viewed a property for rent. Okay, so there is going to be two tables. Here we are just going to perform a join operation. So what is going to be your join operation? Here we are going to select the column values. So I have just used my projection operation here, which is your when I denote pi, it is your projection operation, right? So it is a projection operation for your client number. Okay, client number attribute, first name attribute, and then your last name attribute. Okay, so first name and last name, we are just going to retrieve all these three attribute values. So the projection operation is going to be on three values. From which table? From the table client, and we are going to combine the both the tables. Okay, so the another table is called as viewing. Okay, so you're just going to combine two tables, client table and viewing table. Okay, so inside your client table, you're just going to fetch three attributes. One is your client number, first name, and then your last name. Next, when you perform your prediction operation, I mean your equijoin. Okay, I mean here it is generally theta join. Since the predicate function used here is equal to, it becomes an equijoin. So the client dot your client number, from the client table you're just going to fetch your client number, and from the viewing table you're just going to fetch the client number. You're going to check both the client number of both the table, okay, of client table as well as the viewing table is equal, then we call that particular join as your equijoin. So with the help of these, what are the values we are going to fetch? We are going to fetch client number from your client table, first name from your client table, last name from your client table, and same way we are going to fetch client number from your viewing table and client property number from your viewing table and your comment from your viewing table. Okay, so this is how we perform an equijoin. The projection operation happens and you perform an inner join, and with the help of your inner join you will be able to obtain your viewing client number, then your client property number, property from your viewing table, and comment from your viewing table. Okay, so this is a simple example of your equi-join. Here you have to keep in mind that every time when you perform an equi-join, your comparison condition, that is your predicate f, is going to be your equal to, or if you want to check, you can also check your less than value or greater than value, whatever comparison condition you are using, that is going to be your predicate function. Next one, it is your natural join. So inside your natural join, it forms a Cartesian product again. Okay, like any other join, it forms a Cartesian product. Here, when a Cartesian join, it performs based upon your two arguments. Okay, so first thing, it works on the selection by forcing the equity. Okay, so if you find any two columns in that particular table equal, then you can identify that particular join as your natural join. And one more important thing in this natural join, if you don't have, if you have number of duplicates in your values, okay, number of duplicates in your values, it can be removed. Okay, so that is the main important part of your natural join. Okay, so by definition, equi-join of relation R and S over all common attribute X. Okay, so it will work with all common attributes. Okay, so for example, if you have the common attribute name, employee ID, and the common, or you can keep the employee table with a department ID as a common name. And if you take another entity as S, and inside that S entity you have department ID, so this is going to be a common value that is assigned among these two tables. So inside your equi-join, if you have relation R and S over all common attribute X. Okay, so X, it is not mandatory that there should be only one common attribute. That you can have n number of common attributes along with it. Okay, and the next important point is the one occurrence of each common attribute eliminated from the result. Okay, there will be only one. That's what I mentioned. The duplicate values will be removed. Okay, so only one common value only one common value which is there in the table can be used. Okay, the other values cannot be used, so all the other remaining values has to be neglected or it has to be removed. Okay, so this is how we perform a normal natural join. Okay, so inside your natural join, your name is consider, for example, you have an employee table. Inside that employee table you have name, eid, and your department name, and you have another entity, that is your department, and inside the department you have only two columns or two attributes, that is your department name and your manager. When you try to perform a natural join, okay, when you perform a natural join, here in these two tables, there is only one common attribute, that is your department name. Okay, so any person or any employee will definitely belong to some particular department. Okay, so that is going to be your main part. Okay, so when inside your department name, you can use finance and then your sales. Consider you have two values in the employee, three values in an employee table, and you have two values in your department table. Okay, when you perform a natural join, okay, so when you perform a natural join between these two, your Cartesian product has to be 3 into 2, it is going to be 6. But since it is a natural join, it removes duplicate. What will happen is that you will have only one value that is available for your each join. Okay, so either it will create one record for finance, another record for sales. Okay, and if your main table has your three values, okay, for example, if you have three employees, your duplicate value or your Cartesian product value has to give you 6 output, but it will provide only three values, since other value whatever it is given here will become a duplicate value and it has to be removed. Okay, so this is all about a natural join, and we'll see an example for natural join here. Okay, so here we list the name and comment of all clients who have viewed the property for rent. Okay, so in the previous question also we had two table, one is client and next one is viewing. Okay, here we are just going to use the same two tables. Okay, so one table is client and second table is viewing. Okay, here we are just going to work on the attributes. So instead of selection operation, we are moving into projection operation by denoting a pi symbol there. Okay, so first we start off with your client value. Okay, so you start off with your client value. You don't have a condition that is given here. Okay, the important difference between theta join and your natural join. Okay, so there will be not be any comparison condition. All of these are joins only. Okay, it all comes under the category of inner join, but inside this natural join you don't have a comparison condition. That is, your predicate f is not available in your inner join. Okay, so when you want to perform a natural join operation, you can directly go ahead and pick whatever attributes that are necessary. Okay, so whatever attributes that are necessary, and then you can perform a combine operation. And one important thing, when you have a duplicate value, it will be removed. Okay, so inside this example here, when you look at this image, you have your pi representing your projection operation, your attribute value client number, your first name, your last name, and inside the table client. And next one is your client number, property number, and comment section of your viewing table. You are going to perform a viewing operation. Okay, so in this previous slide, if you see here, if you have how many number of first names, so you have John, you have Alice, and the next record is also Alice, and third one is Alice, and fourth one is Mary. Okay, and I mean you have 5 records here. So inside this record, when you start working it, okay, so here when you look at this, you have the number of records given here as John, Aline, and Mary. Okay, so all these things. Here you are performing inner join. Okay, when you look at this particular join, you will be able to identify if, for example, if there is any common attribute that is missing. For instead of excuse me, instead of using your property number as pg for all these things, then what will happen is that you will have only one align value inside this table. Okay, you will not have all the align values here. Okay, one particular individual independent record for align alone. Okay, so this is how you perform a natural join. Okay, when you start working with your natural join, you have to you will must be able to write your own algebraic expression. Okay, so you must be able to write your own algebraic expression depicting your natural join. Okay, so this is how we perform a natural join, and we just move on to your outer join. Okay, so normally when you perform an outer join in your SQL part, you will be able to identify or join values like complete table. Okay, you can join your complete table. Okay, entire table values can be joined. So this type of join operation, you call it as your outer join. Okay, either it can be of many parts. Okay, either it can be a left outer join, or it can be a right outer join. Any kind of outer join can be performed. So we inside your join operation, there are inside a join operation, there are left outer join, right outer join, and full outer join. Okay, so this is how you donate your join operations. Okay, so with a infinity kind of symbol but open at one end. Okay, so this kind of notation is called as your outer join notation. Okay, here you it is used to display row in a result. Okay, it is used to display the tuple values. Okay, that do not have matching values in the join column. Okay, it will display all the result. Okay, so it is performing not only, I mean, it's not only pick your primary values or your primary key values. It will just get all the values from your both the table. Okay, if you want to perform a left outer join, okay, if you want to perform a left outer join, you can perform it based upon your R entity and your S entity. Okay, so in your R entity and your S entity, if your R value has two matching values of S entity, it will display that value, and along with that it will display the other values where it does not have any matching value. That value will be given as your null inside your table. Okay, so this is how you perform your left outer join. Okay, tuple from R that do not have matching values in common column of S included in the result relationship. But in the natural join, when we saw that there are possibilities that you can have your duplicate values displayed. There are possibilities. There is no possibility that a duplicate value can be displayed inside your natural join. But whereas in your left outer join, it will concentrate on the R entity, and all the values in the R entity will be displayed. Whereas if you don't have a matching value in your S entity, it will be portrayed as null. Okay, it will not leave out all the values. Okay, since it does not have a matching value, it will display all the values. Okay, it will display all the values, and it will perform an S operation. It will perform a in left operation, and then it will display the result. Even though if the value is not there, a null value will be placed inside your outer join operation. And the next one is that inside this itself we have another set of join, that is your right outer join. So right outer join is very similar to this operation. Okay, so right outer join, what does it say? Your right outer join helps you to get the tuple from your S entity. Okay, even though you don't have any matching values or in the common column. Okay, in the common column, consider your primary key column is going to be your department ID. Whereas if you don't have a matching department ID in the other table, you can display that complete tuple with mentioning that it is a null value, since the join has happened and there is no common value that is available. So these kind of join it belongs to the outer join operation. So first one is your left outer join, next one is your right outer join. Okay, along with that we have another set of operation that is also called as your full outer join. So inside your full outer join, what happens is that you have records. You will be able to get records from all the table. Okay, either from your R entity and from your S entity, all these together. Okay, so you have a both the entities together, that is combined together. Okay, so you will have R entity, you will have S entity. So when you combine these together, you will get all the values from both the table. Wherever the attribute is not common or wherever the attribute is not matching, at that position you will have null given inside your each and every column. Okay, so these are the basic join that belongs to your relational algebra, and this is how you represent your complete relational algebraic expression. Okay, so the sample expression we saw here, this is how we represent your relational algebra. Okay, so we'll just walk through what are the things we just gone through. First one, inside join we have various type of join. Okay, and inside that theta join, we just saw what is a theta join and what is an equi-join, natural join, outer join, and a semi-join. Okay, inside that join, when you have your predicate functions that is denoted, then based upon your comparison condition, the predicate works. So if it is less than or less than equal to, greater than or greater than equal to, then your predicate, your join operation is called as your theta join. If at all your predicate function is going to be equal to, then you call that as your equi-join operation. Okay, next one is that your natural join. So natural join is something that happens based upon your common attributes. So common attributes for both the entity R and S, whereas once the common attribute is eliminated, okay, eliminated from the result. Common attribute is considered, the duplicate value among these common attributes can be eliminated from the result. Okay, so this is all about your natural join, and this is an example of a natural join. Next we saw about your left outer join. Inside, outer join which combines all the entities of your R and S. Inside your outer join we can have a left outer join, right outer join, and full outer join. So inside your outer join, what are the things that we have? We have the common values matching in your left side table, that is your R entity, will be displayed. Even though it does not have a matching value in your S entity, it produces null for that particular value inside your output table. Next one is your right outer join. When you talk about your right outer join, the tuples from S join, okay, even though it does not have a matching value in your R entity, it will display your null value. And next one is that your full outer join. So your full outer join also works in the same format. Okay, it does not, it combines all the values in your R entity and your S entity. When you combine both these things, wherever the attribute value is not matched or wherever the attribute value is not given, that place we fill a null value and then you perform a join. So wherever you use join, okay, whenever, if you have a place wherein which you can combine these two values, okay, whenever you combine these two values and you retrieve a value, whenever you need to get values from two tables based upon certain conditions, you can go for these type of joins, and these are the ways in which you can represent an algebraic expression. Okay, the next topic we are just going to see about is your tuple calculus. The tuple calculus, so by the word tuple itself, we already know that it means the record in every table. Okay, every single row becomes a tuple. Okay, every single row in your table becomes a tuple. Okay, so it is related to every attribute in the particular table. Okay, so either it can have value, either it can have unique values, or it can be a any kind of key. Okay, it can be a primary key, or it can be a candidate key, or it can be a super key. Any kind of key can be there, or any type of values. Okay, any format or any data can be given inside a tuple. Okay, it blindly, when you say tuple, you can just identify a tuple. It is one row of one particular table. Okay, any row of one particular table. Okay, or it belongs to one particular entity. It holds the complete value of the particular entity. Okay, so how it is related to your calculus, I mean the way in which you are going to represent a query. Okay, it is a non-procedural query language. Okay, it will not give you the exact what to say, it was just an expression like in relational algebra. How we saw, it is just going to be an expression. Same way your tuple calculus is going to represent your query in an expression, but it is not like a relational algebra. Okay, so it is not completely like a relational algebra. In relational algebra we saw about selection operations and projection operation. Here it is just going to depict, or you are going to write the query in a different format. Okay, so your relational algebra is focused on how you do the process. Okay, how a relationship happens between two entities, but here we are just going to depict a query in one particular format. Okay, your tuple calculus provide only the description of the query, but it does not provide the methods to solve it. Okay, so it just describes the query. It will not give you a solution. It just describes a query. Okay, the query is expressed in the following notations. Okay, so what are the notations that we are going to use? A set bracket. Okay, so every query will start with a set bracket and close with a set bracket, and this pipe symbol, it denotes the term such that. Okay, it is called as your such that operation. Okay, next one is your p bracket of t. P of t depicts your predicate calculus. Okay, so we already saw this word already, right? So when we define a predicate function, okay, whenever we define a predicate function, that time we use the term f. Okay, inside the inner join we saw few examples, right? We used this. So same way here, inside the predicate value we are just going to represent t. Okay, every t that is given inside the algebraic expression, I mean in tuple calculus, is going to represent a row of a table. Okay, any row of a particular table. Okay, so these are the basic things that you have to know when you get, before getting into a tuple calculus. Okay, so the first thing, every time you start writing a query, that query is going to be your inside your set donation symbol. I mean, it has to be notated with your set operation. Okay, so any query. So for example, your tuple T1, that is going to be the first row of your tuple, and you call that row as your T1, then you can represent it in such a way that T1 comma A1, which means T1 A1. So T1 represents the row, first row, and A1 represents the first attribute. So your complete table or your complete entity can be represented in this format. Okay, when I write T dot A, okay, or T1 A1, it represents the column A of the tuple T. Okay, it is the first row, or when I represent T1 A1, it represents the column A1. Okay, so the first value in your column A and the first row of your table T1. Okay, so I mean first row of your table T1 represents the first row of your record. Okay, first row of your record. So this is the basic things that you have to represent. So everywhere, whenever in the query I write T, it is meaning that it is representing one particular record. Okay, that is your tuple, one particular row in your table. And next is your predicate calculus. So you are going to give an expression how you are going to depict the query. Okay, so instead of writing a query in a normal English language, we are just going to write it in a formatted manner. So that's what your tuple calculus gives. So here when you look at this expression, so we already know that we are going to write every tuple calculus expression with the help of your set bracket. Okay, your set bracket, opening your set bracket for T such that P of T. So it is meaning to say that where T is going to be your resulting tuple. Okay, so here the T is going to be your resulting tuple. And when I talk about P of T, it is known as the predicate, and these are the condition that is going to fetch the data. So P of T means, so if you're, for example, if you're going to give amount greater than 10,000, so if that is going to be a condition, it has to be given inside P of T, whereas P, wherever predicate comes, that it defines the functionality, it defines the comparison condition. Okay, any condition for extracting the value from the table, so that is going to be your predicate value. Thus it is generated, I mean it is here it this particular set of expression gives you a value that set of all tuples. Okay, set of all tuples, that is all the records in your table, such that P of T, that is your, based upon the condition that is given in P of T, that is your predicate function, is true for T. So this simple expression denotes that all the records in your table for the condition P of T, that is your predicate condition, is going to be true. For example, you are going to fetch the students whose age is less than 15. Okay, so if you want to fetch the data like that, you can write it in such a way that T such that another T, wherein which belongs to the table student, inside the bracket you can write age lesser than 15. So this expression, this tuple calculus expression, is denoting that it can be given in one particular format, so that the query is exactly depicted in another set of expression. Okay, next, P of T may have various conditions logically combined. You can have your or condition, and condition, not conditions that can be given inside. So here it is mentioned that when you write it belongs to, okay, so when you write the value as this part, it tells you it belongs to. Okay, and it is given as your such that. So we'll see inside the next page where it's just given. So what are the main thing that is given? Okay, when you write it in E format, it denotes your belongs to notation, and when you write it in a reverse format of this kind, then it tells you there exist. Okay, so this symbol denotes there exists, and you write it in this particular format, this symbol denotes that it is an or not operation, and you write it in this format. Okay, it is normal V, then it is your or condition. When you write it in your upward intersection formation, then it is your and operation. So before writing your tuple calculus expression, you must know the basic of what it is. Okay, so these are the terms it belongs to. Whenever I say it belongs to, this symbol has to be used. Whenever I say there exists, this symbol has to be used. Whenever I say not expression, this symbol has to be used. And whenever I say your and or your or operation, all these are the terms that is used when you represent a query into a tuple calculus expression. Okay, so we'll just see how a tuple calculus works. So here inside this part, we just saw what a T belongs to. I've just given an example here. So, which means T tells you, okay, T is a tuple that belongs to such that where the T belongs to. Okay, so the T is the record. Okay, that record belongs to the table. Okay, which table it belongs to? It belongs to the table student, and that record should have the value greater than or equal to 15, of age 15. Okay, here they are just trying to fetch the record, or the question will be in this format. Try to write an expression for where age of the student is greater than or equal to 50. So if it is given in that format, your example has to be written in this format. Okay, so initially we start off with a set operation where T is going to be your set operation and your pipe symbol. Okay, so your pipe symbol, that is going to represent your pipe symbol, that is going to give your T operation and your pipe symbol, and then where this T belongs to, and the T belongs to your table name. Okay, such that T belongs to your table name student, and the T, the record has to give the value of your age. Okay, age is an attribute here, greater than or equal to 15. Okay, so here T is a tuple variable. It denotes all the details. Okay, so each and every record in your table is denoted by T. Okay, and displays all the student details from age greater than or equal to 15. Okay, so this is how you depict your normal tuple calculus value. So this is a normal simple expression of how to represent your tuple value. Next one, I have just given you a few queries here. Okay, so here they have just asked one particular query. The column value, the table from which I'm going to extract the output, I have just given it in the right side, and the output table is given in the left side. Okay, so first question, find the loan number, branch, amount of loan of a of greater than or equal to 10,000 amount. Okay, so here they are just asking us to retrieve the value from the table loan. Okay, loan number, branch name, and your amount. Okay, so which branch they belong to and the amount. See here in this example, they have just given 3 columns, but in the question they have also mentioned only 3 columns. That's why your loan table is given as such. Okay, so otherwise, if you want specific attribute, your projection has to be of that specific attribute only. Consider you have 10 attributes inside this table, and the query is just only for loan number, branch, and amount. The query cannot be written in this format. Okay, it has to be depicted in another way. So for this question, you can directly write it that a set operation opening with T such that the record belongs to which table? The record belongs to your loan table. Okay, the record belongs to your loan table, and where the amount. Okay, every record where amount is greater than or equal to 10,000 has to be fetched. So in this example, if you see, you have 4 amount values here. One is 10,000, 15,000, 9,000, and 65,000 is given. Okay, so here 9,000 is alone eliminated. Okay, other than that, every record is used here. Okay, so so in normal SQL terms, if you want to write it, you can just give it as select star from loan when amount is greater than or equal to 10,000. So instead of writing in a query pattern, we are representing the same answer in a tuple calculus format, in a tuple calculus expression, that is T such that T belongs to loan table, and the T value has to be greater than or equal to 10,000. Okay, so this is how you write a value. So T amount is a tuple variable, and loan becomes your table value, and the attribute individual field value is 10,000. Okay, so 10,000 is going to be a condition. So it gives you a particular condition, that is your predicate. Your predicate is greater than or equal to. And next one is that we'll see another example. Here you have to find the loan number of each loan. Okay, so you have for each who is greater than or equal to 10,000. So you're just going to identify the loan number. So you're just asking for one specific column. In the previous example itself, I told you, right? So if you have 10 columns inside a table and only if 3 is asked, the query has to be represented in different formats. So here, whenever we are just going to write the loan number, okay, we are just going to fetch only one particular column. So your projection, when we talk it in the terms of an algebraic expression, it is just a loan number. Okay, so we're just going to focus on one particular column alone or one particular attribute alone. but here they have just asked for one loan number and they have just asked them to compare it with another value that is going to be your amount. So for this expression, you will start writing the expression with your set query. Okay, the set operation where t such that there exists. Okay, here we are using there exists because we are going to check the condition and then use. Okay, where s belongs to, okay, where s belongs to loan, where t of loan number, that is your tuple variable, is equal to s of loan number. Okay, so the loan number of two tables is compared here. Okay, and s of amount is greater than or equal to, so that it will help you to fetch the value from the table loan where the amount is greater than or equal to 10,000. Okay, so in normal SQL format, when you try to exact the value, your query statement will be in this pattern: select loan number from loan table where amount is greater than or equal to 10,000. That's all. Okay, so the simple format of representation, it is not going to give you a logic here, but it is going to depict the query how you are just going to write it. Okay, so it is a set operation that is happening for the record, for all the records, so that such that t such that there exists s belongs to loan. Okay, s belongs to loan, and the tuple value of loan number is equal to the tuple value of s, and it is just checked against the amount greater than or equal to 10,000. Okay, so this is how you write a tuple expression. Only the loan number column is displayed inside this answer. Okay, the next one is your another example. Find the names of all the customers who have loan and an account at the bank. Okay, so we're just going to check on two tables. Okay, so two tables we're just going to compare and we're just going to get the output. Okay, for this question, they're asking to find the names of all the customers who have loan and account at the bank. Okay, so he is a part of a bank and he has taken loan from that particular bank. So who are all the people has to be selected. Oh, so from this we have to retrieve the value that who is the customer who has applied for a loan from that particular bank. So the starting of the expression. So if you want to retrieve the answer for this particular question, so in a normal SQL statement, you have to perform an inner join. Okay, you have to check the customer name in the borrower table and the depositor table, or inside a customer table. Here the customer table is given in the name of a depositor. Okay, you have to perform an inner join. So inner join will fetch you the output of the customer's name, whoever has taken loan from that particular branch. So here in this example, when you see the names Surab and Meka and Ria, so three names are given here. So whereas in this table, when you look at this card, Surab and Meka are going to be the person who has applied for the loan from that particular bank. Okay, so here when you want to write the answer, you can give it in the set formation. So in the set formation, you have to go to each record. See, why it is mandatory that t has to be given in, because we are going to work only with the tuples. So why it is mandatory? Because whenever you execute a query, the query has to hit the database for each and every row. Okay, each and every row of the table, it has to be checked. Okay, so that's why this t is given in the front. Okay, it has to fetch. It is a row operation, it is a tuple. Based upon the tuple, you're doing the calculus, you're performing a predication. So that's why here t has to be given in front. Okay, so whenever you execute a query, even though you have 10,000 records and only 5 records has to be taken in the output, every time it has to check all the rows whether it is matching or not. Okay, so that is the reason why the t has to be, that is the tuple has to be given, because it has to check all the records and give you an output whether it is given or not, whether it is matching or not. Even though it has 10,000 records and you have only five records in your output, it has to check all the 10,000 records and give you an output. Then inside this t, that is such that there exists s belongs to borrower, where t of customer name. Okay, the tuple, the attribute value customer name is equal to the customer name of the second table. Okay, that is going to be your borrower table. Okay, borrower table and your depositor table. You have to check whether these two columns are equal, and along with that, and you perform an AND operation, you get the value of your depositor table, that is T of customer name, that is equal to U of customer name. Okay, so you are performing an inner join between borrower table as well as your depositor table. So when you perform an inner join, you will get the output as those two names which is matching inside your output table. So when you perform an inner join, here the logic of inner join is not depicted, but still it is this tuple calculus expression says how an operation can be performed. Okay, so it is asking us to check from the borrower table where the depositor table is belonging. So whether the name in the column, attribute name, customer name from both the table, borrower table and depositor table is matching, then the query executes and the output is fetched. We will see one more small example. Here they have just asked to find the value. Sorry, these symbols have been modified here. So find the name of all the customer who are having the loan at this branch. Okay, so the branch name is borrower, depositor and loan. Okay, so here this symbol depicts your such that, okay, so here in this query we can see here, if you have the record P such that there exists belongs to. So what is the question that is asked here? Find the name of all the customers who are having the account in the branch ABC. So here you have the customer borrower name, here you have the depositor name, and based upon this customer borrower deposit, you can fetch all the values. Okay, so all the values you can perform an inner join between the borrower table and your loan table. Okay, so your borrower table, whoever who has fetched the loan is going to be in your borrower table, and the loan details is going to be inside your loan table. So for identifying the branch, you can compare it with your branch name ABC and you can fetch the particular value. So you can write it in this format, right? Set operation T such that there exists S of belongs to your borrower name, that is equal to your customer name in the borrower table as well as your depositor table. You have to match the value and check whether those output, okay, that output is matching with the branch name ABC. If at all you perform an inner join, you will be able to retrieve the values from both the tables. So here I've just given another example of how to write a simple tuple calculus expression. Okay, so here first one is here. I've just given few names here. We'll just read out the query and come back here. So here find the branch name, loan number and the amount for loan $1,500. Okay, so when you want to write a query for that name, so these are the entities or the tables that are available: your branch, customer, loan, borrower, account and your depositor. So this particular set operation can be written in this format for the record such that T belongs to which table? Loan table. Because the query they have asked here to is to get the value from your loan table. So your loan has two attributes, loan name and branch. Okay, so the loan number, the loan table along with your T amount, where amount is greater than 1500. Okay, so it will list all the loan which has the amount that is greater than 1500, that is 1500. The people who have taken loan more than 1500 will be listed here, and it is a combination of a selection process and the projection process. Okay, so here you do a selection as well as a projection process. Why? Because you select the people who are having amount greater than 1500 and you project the particular columns alone. What are the columns you need? Branch name and loan number. Okay, so this is how you write a tuple calculus expression. And one more last example we'll just see. Find the loan number for each loan of an amount greater than $1,500. Okay, so loan number for each loan of amount greater than 1500. So we are just going to compare the loan numbers here. Okay, and only the loan number is going to be your output. Okay, you are doing a projection operation. Okay, so you're doing a projection operation here, and when you select amount greater than 1500, your selection operation also comes into picture. Okay, so when you write a tuple calculus expression for this, you have to write it in a set bracket where T such that there exists L denotes your loan table belongs to your loan. Okay, L belongs to your loan where T, the tuple of loan number attribute, is equal to the tuple that is inside your loan table. Okay, so these two values has to be compared. Every tuple in your loan table has to be compared with your loan number and also with your loan amount that is greater than 1500. Okay, so L denotes which table? It denotes the loan table. L denotes your loan table, and the amount greater than 1500 has to be retrieved from this particular operation. So this is how you write your tuple calculus expression. Tuple calculus expression. So we'll just go through what we have just saw. So we just saw how a tuple calculus works and how we can write with the help of your set bracket operation. You start the basic format, that is a basic format, and your pipe symbol denotes your such that operation, and P of T represent your conditions. Okay, that is your predicate calculus, and T represent every tuple or every record in your particular row. Okay, and next we saw what are these notations used, that is belongs to, there exist, not, and, or. So these are the basic expressions that is used for writing your complete tuple calculus format. Okay, so this is how you write one particular example. If a query is given to you, then you can mark that particular, you can depict that particular format into a tuple calculus expression where the complete query is understood and it is written in the based upon your tuple calculate along with the predicates, that is your logic, that I mean that is your functionalities that is given inside. Okay, so this is how you understand your tuple calculus. Thank you.